Okay, in this video, I'm going to go over the solving inequalities notes. Let me click through. It started at the beginning of my presentation. Here we go, this guy. All right, so solving two-step inequalities is just like equations. For the purposes of this video, just if it's underlined or bolded, that's what goes in your fill in the blank. So our goal today is to solve an inequality and graph the solution. Okay, so these four symbols are the inequality symbols, okay? So greater than is this guy, greater than or equal to is the same as greater than, but has the equal to line underneath it. This is the less than symbol, and this is the less than or equal to symbol, again, having that equals to line. So one way to start off working with variables and less than symbols is to graph them. So here are the steps to graph an inequality. You're first going to label the number that you're given, then one number to the left and one number to the right. Then you put a circle on the number that you're given in the inequality, and then you color in what makes the inequality true. So here, x is greater than 3. I label my 3 because that's the number I'm given. I label one number to the left, which is 2, and one number to the right, which is 4. And then I put a circle on the number in the inequality. Notice that it's an open circle. I have not colored it in. This is super important, okay? We'll get to that in a second. All right, and then you're going to, instead of x, put in these numbers. So instead of x, I put in 4, and I asked myself, is 4 greater than 3? Yes, that is true. Okay, so I would get to color that in a second. Then instead of x, I'm going to try 3. Is 3 greater than 3? No, 3 is equal to 3, but it's not bigger than itself. That's kind of a silly statement. So I do not get to color in the circle because that is not true. And then is 2 greater than 3? Also no, 2 is less than 3. So we're going to draw an arrow pointing to all the numbers that would be greater than 3. So it's going to be an arrow pointing to the right because 4 would be greater than 3, 5 would be greater than 3, 6 would be greater than 3. So this arrow means that any number that's this direction on the number line is going to be greater than 3. X is less than 7. So I put 7 on my number line, and one number to the left, which is 6, and the number to the right is 8. Put a circle on the number, so on 7. Haven't colored it in yet, don't know if I can. And we're going to pick test points. So instead of x, I'm going to try 8. Is 8 less than 7? Nope. Is 7 less than 7? No. Is 6 less than 7? Yes. So I get to draw my arrow this way that says I can put any number in for x that's this way on the number line. So 6 would be less than 7, 5 would be less than 7, 4. Any number that's this way on the number line is going to be less than 7. All right, y is greater than or equal to negative 5. We label negative 5, 1 to the left and 1 to the right. Remember that as it goes left, it gets less and becomes more negative. We put a circle on the negative 5. Then I choose test points, okay? So instead of y, I'm going to put negative 4. So is negative 4 greater than or equal to negative 5? Yes. Negative 4 is greater than negative 5. Then I try negative 6. Is negative 6 greater than or equal to negative 5? Nope. Negative 6 is less than negative 5. It's also not equal to negative 5, so I don't get to color that direction. Last but not least, I put the number itself. Is negative 5 greater than or equal to negative 5? Yes, because it is equal. So that means I get to color in the dot. And I draw my arrow to the right because that is showing me all the numbers this way are going to be greater than or equal to -5. Last one, W is less than or equal to 0. So we're going to label 0 on our number line. 1 to the left is -1, and the number to the right is +1. Put our circle on 0. Don't color it in yet. We're not sure. We have to test it out. And instead of W, I'm going to put actual numbers, right? Because variables just hold the place of numbers we don't know. So is 1 less than or equal to 0? It's neither of those. It's not less than 0. It's not equal to 0. Okay, is 0 less than or equal to 0? Yes, it is equal to itself. So I'm going to get to color in that dot. And then is -1 less than or equal to 0? Yes, -1 is less than 0. So I draw my arrow this way to show that those are all the numbers that are going to be less than 0. And I color in that dot to show that this is the number that is equal to 0. All right, so let's talk about actually solving them. Okay. So inequalities are not really that different than equations, okay? This prefix of IN means not. So in your notes, underline that, okay, and write that it means not. And then next, I have this base word of equal, this root, okay? So inequality means not equal. That is literally the only difference between inequalities and equations. Okay, you solve them the same. It just doesn't have an equal sign. Okay. All right, there is one special rule. Okay, so make sure you write this on your notes. When you multiply or divide by a negative number, so when the number doing the multiplying or the number doing the dividing is negative, you flip the direction of the symbol. We'll get there in a second. Okay. All right, so these are kind of out of order. You'll have to sit tight with me as I go through them. So this is actually the second example. So just like we would normally do, we have to first undo our constant. Okay, we put a line through our symbol, just like we would the equal sign. Okay, -7, or this -7, is my constant. Okay, it's the number that's being added or subtracted to the letter. The opposite of -7 or -7 is +7. What I do on the side with the letter, I have to do on the other side. Then I'm going to simplify that. So the point of this +7 was to cancel out the -7. And I still have 1/4 m, so I'm going to bring that down. My inequality symbol comes straight down. And then 2 + 7 is 9. Then I have to undo my coefficient. My coefficient is 1/4. 1/4 m means 1/4 times m. The opposite of times is dividing, so I'm going to divide by 1/4. Then I'm going to use my handy dandy calculator. 1/4 divided by 1/4 is 1, so this just gives me 1m. I bring my inequality symbol straight down. 9 divided by 1/4 is 36. Feel free to use a calculator for that one. All right, so to graph this, we put 36. We label it on our number line, 1 to the left and 1 number to the right. Our circle goes on 36, and then we color in what is true. So this bit down here, you don't have to write this in your notes if you don't want. I'm just showing you my thinking, okay? So instead of m, I'm going to replace it with 36. Is 36 less than 36? It's not. Okay. Then I'm going to try 37. Is 37 less than 36? Nope. And is 35 less than 36? Yes. All right, side note. Here's a helpful hint. If it's to the left, it's less. They both start with L. So my arrow is going to point towards the left, saying that all these numbers, if I substitute it back in here, it will give me an answer that is less than 2. All right, this is the top one. 3n minus 4 is greater than 29. Put a line through your symbol. My constant is a minus 4. The opposite of minus 4 is plus 4. I must do that on both sides. So it gets rid of the 4's. I'm left with 3n, so I'm going to bring it down. 29 plus 4 is 33. My inequality symbol comes straight down. Then I have to undo my coefficient. 3n means 3 times n. To undo times, I'm going to divide. 3n divided by 3 is 1n. 33 divided by 3 is 11, and my inequality symbol comes straight down. So as long as my number that I pick is greater than 11, this original inequality will be true and it will work. So to graph it, we put 11, 1 to the left and 1 to the right. Put a circle on 11. Okay, is 12 bigger than 11? Yep. So I'm going to get to draw something, color something over there. 11 is not bigger than 11. I do not get to color in the circle. And 10 is not greater than 11, so I don't get to draw my arrow that way. So you color in what makes it true. So any of these numbers, if I picked 13, 13 would be greater than 11. 14 would be greater than 11. This arrow just means any number that's this way on the number line is going to work. All right, so getting to our special rule about negatives. We solve it the exact same way. Okay, I have to undo my constant. My constant is minus 9. The opposite of minus 9 is plus 9. That cancels out the minus 9. I still have a negative 6x, so I'm going to bring that down. My inequality symbol comes straight down. And then 33 plus 9 is 42. Then I have to undo my coefficient. Negative 6x means negative 6 times x. To undo multiplying, I'm going to divide by negative 6. What I do on the side with the letter, I have to do on the other side. Negative 6 divided by negative 6 is 1x. 42 divided by negative 6 is negative 7. But this is my special rule. The number doing the division was a negative, so this symbol is now going to open the other way. All right, so to graph it, we put negative 7, 1 to the left, 1 to the right. Put our circle on negative 7. We think about our test points. Is negative 6 less than or equal to negative 7? It's actually less negative, so it's going to be greater than that. So I don't get to color that. Negative 7 is equal to negative 7, so I get to color that in a second. Oops, wrong way. And then negative 8 is less than negative 7, so I'm going to get to color that in. So since this was equal, I get to color it in. And I'm going to, oops, wrong way, draw my arrow that way. All right, last one. Cross off this right here. It won't let me on here. But get rid of that V. We don't need it. So put a line through our symbol. All right, this time my constant is 8 over here. It's the number that's by itself. So to get rid of 8, I'm going to do minus 8. What I do on this side, I have to do on this side. So that gets rid of the 8. I'm going to bring the negative x over 2 down. I'm going to bring my symbol straight down. Then 88 minus 8 is 80. All right, then my coefficient x is being divided by negative 2. So I'm going to do the opposite, which is multiplying by negative 2. This should really be x. Okay, so that gets rid of the 2's. 80 times negative 2 is negative 160. And then since the number doing the multiplication was negative, we flipped the direction of the symbol. All right, and then we're going to skip graphing it. All right, and that's it.